Yeah, so I'm Will Burgess, and I'm going to be speaking to you today on linkers and loaders experiments with Crystal Palace. So I am the technical lead of Cobalt Strike. My background's a mix of red and blue. I've actually worked with a few people in here. So I started as a sort of threat hunter. I quickly sort of learned how sort of EDRs work, and then naturally did more security consultancy. So, you know, once you know how they work, you can bypass them, etc., and more red teamy stuff. I then did actually like EDR development. So I worked on like very low level ransomware protection, process injection protections, cred theft, etc. Before then working at CS. So I've done like a whole gamut of things. But ultimately, though, I'm a hacker man, and this talk is very much in the vein of that. One of the reasons why I always like CS is because I could sort of do what I want with it and configure it in a way that I could do sort of crazy things, and it was left up to my imagination. And so this talk is on something that Raphael released, but unsurprisingly, his sort of mentality of enabling other people, this is very much my reflections of like another tool set of doing that, and so that's the kind of spirit. Like I might mention CS, but like generally I'm one hacker to another. Like this is about me playing around with something. What's in it for me / you guys? So historically, I think PIC code has been very difficult and extremely painful to develop. I have some anecdotes about this. I don't know if others, but actually I was quite lucky with timing today because Hugo and Dima's talk are both quite relevant to what I'm going to say. But Hugo already sort of described some of these difficulties. But clearly, virtually any malware written for the last 15 years has depended on PIC code. And in fact, the fact that it's been hard to develop has been actually a little bit of a reason why maybe reflective loaders are still even a thing, because of this sort of technical barrier. But clearly they can be very powerful, and the obvious example of this is things like Titan loader, Boku loader, etc., which do very interesting things, but are all PIC and all written by absolute hacker men and women. So I think Raphael Mudge's Crystal Palace, I think, is a real game changer for PIC development. This is my opinion. Hopefully I'll convince you. And so this talk will introduce it, and it's going to demonstrate a new approach to writing modular PIC payloads in a standardized way. And the key thing is we can start reusing these components to do very cool things, and I will demo, hopefully, a lot of interesting stuff. So the agenda is a quick overview of PIC development, basically why it's a pain, my personal sort of development journey with PIC, an introduction to Crystal Palace, and then I have 3 examples. 2 of these Dima has covered. We talk to each other, so it's not a surprise. But the first one is like a novel loader that I intend to release, but at the moment I've just got like a proof of concept. And the other 2 are the same sort of things that Dima mentioned before. So typically, this is really naughty stuff, so I apologize, but if you write some code in C, typically the flow is the compiler will compile that to an object file, and the object file will have like the text section, the data sections, and relocations, etc., but it's not an executable unit. It is supposed to be used by a linker, which will link it with other object files, libraries, and that will make an executable. And one of the key things the object file contains is these relocations. So if you have a string, it won't go in the text section, it will go in the data section. And so when the operating system like runs it, it needs to fix up that memory address so everything works. So the linker will do its best, but ultimately, like when you run an exe, the operating system is going to be the one that fixes up all those addresses, makes sure they all run, and then you're away. And this abstracts a lot of complexity, so you can do very complicated things that we've seen examples of, like standard libs, exception handling, etc., because the operating system does it all for you. This is not the case when you write PIC code. This is really obvious. It must be position independent, but I cannot stress enough that your compiler will cheat and betray you. So you can write something that you think is perfect, and then the compiler, and they all do different things. MSVC will do different things, Clang will do different things. It will either inject external symbols, it will inject jump tables, etc., which will cause crashes. So you're not fully in control of this stuff anyway. And that is actually an interesting problem with UDRLVS that Hugo mentioned. Every time Microsoft release a new version of Visual Studio, they break something because they change a compiler flag and it starts doing something else. So it can be a bit of a nightmare. And then the other thing is, obviously, you have no access to APIs. Like, you're just put in memory somewhere. You've got no idea where anything is, and you have to find it. And finding it like once is one thing, but constantly doing it for every API you knew is quite frustrating. So TLDR, it's terrible times. You've no access to APIs, the C runtime, embedded data, so you can't use strings. The other interesting thing is you can't use global variables because these would be in a different section. So this is another problem with writing PIC code, is you do have to kind of refactor things. And as Hugo said before, historically there's been loads of tricks of like having strings in certain ways so they're stack aligned, all that kind of blah. But basically it is a massive pain. So onto my journey with PIC development. So the first research I ever did was, a long time ago now, but basically I think a very smart man, Josh Lospinoso, released this proof of concept of Gargle, which was the first, probably the very first point of like modern memory obfuscation. And it used Windows timers to basically execute a ROP gadget, which would like virtual protect a bit of shellcode, run it, change it back, and then wait for the timer again. This was cool, but it didn't really it wasn't weaponized. And so what I did was I had to write a PIC stub that would then stage CS and then like unstage it on a timer. And the idea was to sort of break periodic memory scanners, which TLDR are like a bad idea. You want it to be like event-driven because you can just miss all this stuff. And to do that, I had to use, so Matt Graeber, who I don't think is that like public-facing now, but was an absolute legend, wrote loads of the PowerShell tooling back in the day. There's this legendary blog post, again, very old, 2013, which is how to essentially set up like a Visual Studio template to write C that will compile as position independent. And this had about like 40,000 weird linker flags and compiler flags to make it so it would do stuff. And it was honestly like the worst thing in the world. I actually didn't share my code for that POC because it was so bad. Like I couldn't share it, it was awful. And I used to have to like stitch bits of shellcode together, put it in memory and just hope for the best. So TLDR, just awful, awful stuff. Skip forward a few years, and I started looking into call stack spoofing. The actual technique is kind of irrelevant, but the thing that was of interest to me is like to weaponize this. Basically, with beac0n, the only way you can really do it is with a user-defined reflective loader. And basically, this means, again, PIC development. So I start hooking IAT and doing all this like really complicated stuff. And I think at the time, I was just like, oh, I just can't be bothered to do this. Like, it's going to be so painful. And also, it was kind of, it was the means to the end. Like, I didn't want to be the end in itself and faff around with this stuff. So that was partly the inspiration between, again, I don't want to do on this, but like through beacongate, the idea was that like we have like a BOF-VS template, it's very easy just to write BOFs, debug them, step through, etc. And so it's far easier to write it in that way and then, get us to sort of do the IAT hooks for you because sometimes you just don't want to write a loader for quick instrumentation. And I think the thing to note is that a lot of UDRLs, for all their fancy kind of like Titan loader, it's basically a very simple loader and instrumentation. And the instrumentation is only really at runtime. So you don't actually need to have all the IAT PIC development. You can do it another way. And this was one of those ways of doing it. Actually, one thing very quickly, a historical fact about this. So this is the reason behind why BOFs exist. So Raphael also played with this template and basically found it so painful to write PIC that he thought, oh, I wonder if you could abstract it back and just run the BOF file, the object file. And this is one thing that I think is often forgot about BOFs. BOFs are an abstraction around PIC. They are PIC, but with the conveniences of strings and imports. And that's sometimes forgotten because people try to abstract it up, the BOF PE being a classic example where suddenly I want to write some fully fledged thing. I'm not saying it's like a good or bad thing, but just for context, like BOFs are an abstraction above PIC, and so they were never intended to have loads of libraries, etc., embedded. Blah, blah, blah. Right, here's a quick demo of Beacon Gate. So this code is on the internet. It's Sleepmaster-esque, so you can download the repo, and the cool thing is you can debug, step through all these techniques. So this is just an example of building it in release, and then it also has this little CNA that you can import into CS, and this gives you this little selector, so you can really quickly just change in your TTP. So I have like a ret address spoofing one and this Draugr technique. You don't really need to know what the technique is, just more that it exists and it spoofs a call stack because it's relative later. And so this is just an example. I've got a breakpoint on virtual alloc, and this is ret address spoofing. Bye-bye, it works. And then I'll do the same just to confirm. And so this is the concept of quickly being able to switch in and out BOFs with kind of like separate tooling, which is something that I was kind of like passionate about. And there you go, that's the Draugr call stack. The elephant in the room with all this stuff, though, is that so I can easily instrument beacon at runtime, so I can do some of the things that, like Titan Loader does or something, but there are still API calls in the loader which I need to spoof. Load library, virtual alloc are the classic ones. And so my issue is always like, can I reuse this BOF in a way? And I debated even writing like a PIC loader that loaded BOFs. My main thing is, and Hugo raised this before, so there's existing URLs, right? If you look at Titan Loader, A's Loader, most of them are actually based on Austin's code, so they just use his linker script step, but it's still, they all have like their own defines. All the code is like specific to that. You can't like pull something out. It's all template based. We also have like URLVS, as again, we spoke about, but that in itself, again, you sort of need to rewrite it. It's a code source framework, so it's very powerful, but it starts getting very bloated and stuff. And so TLDR, like none of these things really felt right for me. I couldn't really get on with them. And then bloody Raphael appeared, didn't he? Out of nowhere, he released Crystal Palace, and this was almost like exactly what I watched straight away. I was like, oh, that's what I wanted to do. Well, not what I wanted, but like that was my sort of need. And so, what is Crystal Palace? So it's a linker and linker script language that's basically developed for writing PIC loaders. And so the idea is that you can give it a bunch of stuff, it's going to munge it all together, transform it in certain ways, and spit out a PIC blob at the end, and that blob will just magically run. It allows you to run costs from PIC, so this is exactly what I wanted to do before. Like I just wanted to run an object file that did one thing and be able to reuse it. And you can also append like multiple. So it's, I said, a way of just like specifying resources and then being able to refer to them from your PIC, which is, as you'll see, is very powerful. It also allows you to write an object file or a C file and then convert it to position-independent code. And the last bullet point is the main one. It's the modular design of PIC payloads, which, as hopefully I will show you, is very powerful. Here's the basic gist. This is sort of quite complicated and more than I can go into in this talk. And I'm sure you'll probably prefer more demos than me just gassing on about various things. But so this is like a high-level view. But you write your code, you compile it into object files, and then the key thing is you have this loader spec which processes these object files. So this is what tells Crystal Palace, like, what do I want to do with these object files? And you have some examples there, like make pic, which will basically strip out the text section. You can see that it's loading a free object file. It's going to make this into a Pico BOF, and a Pico BOF is basically a BOF without a BOF API. Very simple. Just no beacon API, that's it. And likewise, you can then munge this into this pic blob, and then you can access it via this my BOF symbol. So it's being able to link within pic payloads, which is pretty cool. And then Crystal Palace will take this loader spec, do magical stuff, and then throw out a payload.bin. So here is a very simple demo. So this is like the standard layout. You have the source, This is just going to run a loader which will run this very simple cough, which is just going to free the loader and then execute the DLL. The loader's like Stephen Feuer's, basically. I'm going to build the code now. We see the object files being built. And then here's where the loader spec comes into it. And this is the identical to the one I just showed. So it's going to load that object file, it's going to make it pick, and that's at the sort of top of this stack. It's then going to push the DLL, and the DLL is accessible via my data. It's then going to load this free BOF, convert it into Pico, and then link it so we can access all those things within our reflective loader. As a note, there is, Rasmus has quite good documentation on this. For beac0n, you have to give like an extra call into DLL main. It's not very hard, but they won't work out the box with them. And then that's just a shellcode runner that Raphael includes. Boom, we're away. Right, boring stuff out the way. Here's example one, which, Trade Garden, Eden Loader. Yeah. So I said, my initial objective was, I had this BOF, it's got some cool stack spoofing stuff in. I want to use it in the loader. I don't want to have to rewrite it in a pick template that then is only valid in that pick template, etc. So I used the Draugr one that I demoed before, has a nice looking cool stack. And so my first kind of objective was using Crystal Palace. Can I convert it to a Pico, again, BOF without beac0n API, and then pure pick? I immediately have issues because, so our template, I think, well, the Sleepmaster VS uses Clang, and the reason is because you can do inline ASM. It's just extremely tedious, but MSVC, if you have an external ASM, it will compile that into a separate object file, and you cannot merge it together on Windows, so it's very painful. So for BOFs, it's bad. I'd never used MingGW to write BOFs, and I was amazed, actually, there's hardly any templates, so I assume people just suffer in silence with print debugging, which just seems mad to me. So I could not abide by that. So this actually, Rasmus told me about this, but he did do a blog on it later. But you can actually add debugging support. So you put the G flag in. Again, I will release blogs on this later. So just bear with it. But like TLDR, you can get a debuggable exe, which will have, in WinDebug, you just point it to your source code, and you can debug pick code, which is great, because otherwise it is unbearable. So the first thing I want to do, as I said, is just make a BOF into a Pico BOF. This in Crystal Palace parlance is just load my BOF and make it object/Pico. This is really easy. Obviously, remove any BOF APIs as it won't know what they are. And then, weirdly, it didn't like static variables. So whatever, but once you get rid of these, it was fine. To convert it to pick is a different issue. So firstly, you cannot use globals or static vars. I think the philosophy behind Crystal Palace is to use things the way they work. And interestingly, if you look at other pick templates, like Stardust, I think, initially, under the hood, would allocate memory on the heap and then start putting globals on the heap or something. It's like, whoa, what are you doing? So some of these other templates will do like weird fudges. This just, no, you have no globals. You need to use Picos if you want globals. You obviously have no imports. You can't just do kernel 32/sleep. So you need to resolve by hash. Or I just passed a, Raphael has this convention of like a function point. You just pass what you need and you can just use that. And then you just be careful of the layout. Obviously with pick code, it's going to start at the top. And if your entry point's not at the top, it's bad times and very hard to debug. But there are examples of how to do that. So at that stage, I could convert this BOF to a Pico using a loader, and I could convert it to pick. And it's like an embedded resource, which is pretty easy, good stuff. But that's quite boring in itself. Let's do something interesting. So Raphael had a page stream example that wasn't really optimized for anything. So let's build a loader with call stack spoofing with that. So this, at a high level, is how page streaming works. So your loader loads this Pico at the bottom, which has the vectored exception handler and the call gate in. And then what it will do is it will load two other blocks of memory. One will be the obfuscated beacon, so it's going to like churn through that and just obfuscate. Ironically, in my demo, the header is not actually obfuscated, but just forgive me for that. The other one is just a blank DLL, so it's like a template of beac0n, but there's nothing there. But you then smash guard pages over all the interesting bits that you want to protect. Then what you do is you just start execution at a blank guard paged entry point, and Windows obviously like, what are you doing? it will call the vector exception handler, and then you just stream in the page as it's needed. And so Raphael's one only keeps in like max 3 at a time. The one optimization I had to do is, ironically, the one data page that was left when beac0n was sleeping had like loads of signatures on it, so I had to mask that when beac0n sleeps. But other than that, I didn't have to do too much to sort of tune it. So here is a demo. Here is a more horrible config. You can see the guard exec is the actual page streaming, and then the drawger object file is my pic stub, which I'm going to make pic64. There's lots of debug stuff in here, which you don't really need to worry about, but I was using for sanity checking everything. And then basically the beac0n x64 template is just a beac0n without a reflective loader. And then I'm going to run loader.bin and shells. So if we check in Process Hacker, we can see the memory. This might be a hard view, but this is the obfuscated beac0n. The header's not obfuscated, forgive me, but the rest of it is. There'll be no signatures there. And then this is the guard-pated region, so you can see the read-write guard page. And these are the 3 visible pages. And then the main thread is just the drawger call stack. So I think for my loader, I did it for most of the ETW TI stuff, but obviously sleep as well. So it would just mask the pages, and then call that. Right, on to example 2. So to repeat myself, so Crystal Palace supports loading P-codes as these alternative. One interesting thing you can do is into a Pico, you can link commands into it. And I've said about 40,000 times that Picos are BOFs without a beac0n API, but if we can import functions in, then we can just make a BOF runner. Like, there's nothing stopping us doing any. I mean, most of the BOF API is like relatively simple. And so we can just reflectively load any cough you give, like we like, give its own beac0n API. And then the other nice thing is, Dima raised this without the offset considerations. So generally, at CS, if we release anything that is in memory for a brief period unexposed, it will be signatured almost overnight. So it's very hard for us to take that approach because it just gets, it starts to become very difficult at scale. But Crystal Palace actually allows you to mutate and randomize the function order of object files and pic stubs. So this is obviously like a really attractive thing. If you have a pic API that's like constantly mutated, it breaks that whole signature thing. And the nice bit is also that we can, in that sort of modular way, so the beac0n output is also implemented as a BOF. So I just link beac0n output to that BOF, but that BOF could do anything. It's over a name pipe, but it could be over any IPC mechanism you want. You just need to be able to retrieve it. And so here is a quick demo. So there you can see the name pipe object file, which we're linking. Ignore the hook. That's the next demo. And there's the name pipe object file that we're going to build. So we do a standard Crystal Palace. We're going to build the object files and then invoke Crystal Palace. And this is going to run that whoI, which is just trusted sec whoami BOF has listed there. And it's going to output it as this async execute bin. I have a really bad CNA script, don't judge me, here, which is just going to execute this bin file. Very lazy, poor stuff, I apologize. And so now if I run that very quickly, boom. So already, in fact, this was released like a few months ago, you could already implement an async BOF runner yourself with beac0n API. It's completely independent of CS, which is like pretty cool and powerful capabilities. What's going on here? Into that. But hold on, you might think, oh, this is a bit rubbish. Like, that's not that exciting. And one thing that I think is interesting is if you have these async capabilities, right, if they're doing like really noddy unbacked calls, then it's kind of like, it's going to get you burned. It's not that exciting. But this is the real magic, and this is where I hope to convince you why I think it's like game-changing, is that well, I just showed you, I just had a BOF, which I just used in a loader. Well, I just use it again. Like, I'll just load it and then just redirect it to there. So then suddenly I can have an async pick runner that now has like a COF that does call stack spoofing. And I think to convert this to like a pick template would take hours, and I think people would lose the will to live. But here, I've got it as a BOF, just do it, it's easy. So here we go, YOLO. This is just gonna now run a sleep, a very simple, again, don't judge me, it's a very bad BOF. This is just gonna run debug break, so I can watch in a debugger, sleep, and then beacon output. So again, I'm gonna build it. And you see that, the sleep object's built. And then now, yeah, you can see the sleep is the BOF instead that's being used. So I've got this tenuous thing of showing you the CNA scripting, I think. No, don't do it. Okay, anyway, blah, blah, blah. You saw nothing. So now, if we run that in CS, it will trigger a breakpoint in WinDebug. And so that is the debug break that's been hit now. If I run, if I enable the breakpoint, hit K and F, which will display the call stack, you can see it's a variant, but it's the same Draugr call stack as before. So in the same way that I can do IAT hooking on a DLL, when I load a BOF, I can just resolve the kernel 32 sleep to my call stack, and then we're away. And this is like really, really powerful stuff, in my opinion. The last one is, Dima told me about it, or like was thinking about it, like we had a conversation about it, and I realized the other day that you could, huh? Oh, yeah, and I realized the other day that you could also do this with this, the same thing. Again, lucky Dima spoke about this, but it's the idea of, it's what I mentioned before, it's abstracting up. BOFs are abstracted pick runners. This is now like, oh no, I want a fully fledged like executable that has a beacon API, etc. And so the idea is, as Dima said, you would then link beacon output, and then the implant would then just parse that and be like, I can do that, blah, blah. But I've just demonstrated I can do it with BOFs. I can do the same thing with a DLL. All I need to do is when I'm loading it, if I see like beacon DLL, beacon output, then I just link it to my Pico BOF API. The API can still use the same pick stub. I'm just reusing the same code. And then I can be bothered to do it, but like you could also use the call stack spoofing, etc. as well. And so here is a quick demo of this. I would say, yeah, again, a capability that someone was kind of asking. Well, we can do it yourself already. You don't necessarily need to be restricted. So there you go. This is a DLL that calls beacon output. Actually, I may just pause it there. So that's linked to a lib, which has those definitions. And then basically you compile it and you get the beacon DLL, the imports as similar to what Dima showed earlier. And so now I have a loader especially for this, which will parse those imports and search for the ones we want. And it's going to load that specific BOF DLL. Blah, blah, blah. Okay. And then we'll run this. And you'll just see it said hello world, which was the crappy example that I showed. But TLDR, it's possible. Conclusions. I think it is really powerful. It took me a little bit of time to get up to speed, but once you sort of get used to certain conventions, I found it more and more natural and quick to use. And like the laser things I worked on, I did very quickly, whereas before it took me a bit of time. I think ultimately, again, is that sort of hacker perspective, like I found it really fun. Like the best stuff for Raphael is like just really fun to just have a play, try some stuff out, kind of go wild yourself. So I would recommend it. I think it's really cool. And I do think it is a massive leap in pick development, which I said, I think one of the reasons why reflective loaders are still around is because pick development is like so complicated and just error prone. And I think that might start to change with this already. And I think, as I said, the magic is it's the ability to reuse like independent tradecraft in a standard way, which I think is just the time. I said I think I could rewrite everything I think I've shown in UDA LVS, but I just think it would take so much time. So it's the time and the ease of use which just makes this, I think, a bit of a game changer. And I've also, we have like post-XDLLs and CS, which incidentally, like you can do quite a lot of like monitoring stuff in, but are kind of, again, on us to explain, but they are obviously maybe more wedded to CS, but this is also the kinds of bones of almost like a C2 agnostic like post-exploitation. Like, as I said, all you need to know is just be able to read beacon output. You can use it with whatever. So that is me done. Any questions? And thank you.